The topic of this presentation is based on memory as presented by Steve Bamigbose and Oluwaseyi Akinbade. Memory. This is the second major hardware component of a system, is the memory. The storage bank for information that the computer needs to keep readily available. There are different types of memory, each suitable for different purposes. Types of memory. We have primary and secondary memory. The primary memory is the only type of memory which is directly accessed by the CPU. The CPU continuously needs instructions stored in the primary memory and executes them. Any data that has to be opened by the CPU is also stored. The information is transferred to various locations through the bus. Primary memories are of different types. We have the read-only memory, random access memory, and we have the cache. Read-only memory. There are different types of read memory. Read-only memory, which is also called as ROM, works like the name implies. Its memory the PC can read but can't change. No writing allowed. The content of a standard ROM chips are burned in at the factory, and the end user simply cannot alter it. ROM chips often contain bootstraps information that computers use to start up prior to loading an operating system from disk. This includes the familiar power on self-test, that is post, series of diagnostics that run each time you boot a PC. There are different types of ROM. We have the programmable read-only memory. We have the erasable programmable read-only memory. We have electrically erasable programmable read-only memory, and we have flash memory in a derivative concept from EEPROM. The read access memory, it stands for random access memory. Here data can be stored once and read many. Once chips has been programmed, the recorded information cannot be changed. That is for PROM, which is part of the which is one examples of the read-only memory. Now let's talk about the read access memory. Read access memory, it stands for random access memory. Here data can be stored temporarily, so this type of memory is called as temporary memory or volatile memory, because when power fails, the data from RAM will be erased. The information stored in the RAM is basically loaded from the computer disk and includes information related to the operating system and applications that are currently executed by the processor. RAM is of distinct types like SRAM, DRAM, VRAM. The following are types of RAM. We have the dynamic and static RAM. Now let's talk about the cache memory. The cache memory is a very high-speed semiconductor which can speed up CPU. It acts as a buffer between the CPU and the main memory. It's used to hold those parts of data program which are most frequently used by the CPU. The parts of data and programs are transferred from disk to cache memory by operating system, from where CPU can access them. The processor normally contains an onboard cache of extremely fast memory, which memory used to hold data on which it will operate. This is on chip or level 1 cache is often backed up by a static RA cache on a separate chip called a level 2 cache, which holds data from the computer main register. When we talk about register, the CPU also includes a limited amount of onboard memory known as register. They provide it with direct accessible memory location than the brain of the CPU. The arithmetic logic unit, ALU, uses when performing calculation or processing instruction. Any data that the ALU is to manipulate must be loaded into a register unless it is directly supplied as part of the instruction. The main advantage of this type of memory is that this part of ALU itself and therefore operate in lockstep with CPU at typical CPU speeds. Let's talk about the memory addressing. When using memory resources, the processor must have some means of referring to various locations in memory. The solution to this problem is known as addressing, and there are several addressing schemes used in various circumstances. The following are the 5 of the major common addressing schemes. We have the registered addressing, immediate addressing, direct addressing, indirect addressing, base plus offset addressing. Type of memory continued. Now let's talk about the secondary memory. This type of memory is also known as external memory or non-volatile. It is slower than main memory. These are used for storing data information permanently. CPU directly does not access this memory. Instead, they are accessed via input and output routines. Contents of secondary memories are first transferred to the main memory and then CPU can access it. For example, magnetic disks, magnetic tape, optical disks, flash drive, mass storage devices. The characteristics of secondary memories: they are magnetic and optical memories. It is known as backup memory. It is non-volatile memory. Data is permanently stored even if power is switched off. It is used for storage of data in a computer. Computer may run without secondary memory. It is slower than the primary memories. Now talk about memory security issues. Memory stores and process your data, some of which may be extremely sensitive. It is essential to understand the various types of memory and know how they store and retain data. Any memory device that may obtain sensitive data should be purged before they are allowed to leave the organization for any reason. This is especially true for secondary memory and ROM, PROM, EEPROM, and EEPROM devices designed to retain data even after the power is turned off. Memory data retention issues are not limited to those types of memory designed to retain data. Remember that static and dynamic RAM chips store data through the use of capacitor and flip-flops. It is technically possible that those electrical components could retain some of their charge for a limited period of time after power is turned off. A technically sophisticated individual could theoretically take electrical measurement of those components and retrieve portion of the data stored on such devices. This requires a good deal of technical expertise. There is also an attack that freezes memory chips to delay the decay of resident data when the system is turned off or the RAM is pulled out of the motherboard. The greatest security threat posed by RAM chips is a simple one. They are highly proliferable and are quite often stolen. So we're done with memory. We now talk about the input and output devices. The devices which are used to give data and instruction to the computer are called input devices. Various types of input devices can be used with the computer depending upon the type of data you want to enter in the computer, e.g. keyboard, mouse, joystick, pen, etc. The devices which are used to display the results of information are called output devices. You can view the output on the monitor or you can print it out on using a printer, monitor and paper and printer are the common use of output devices. An example of an output device is also is a speaker, which actually when you connect it to your computer, it brings out the sound. This is the end of the presentation. We have our reference, which you can actually check for more updates, more information about the presentation. Thank you very much.